Welcome to Out of the Lab, a podcast interviewing entrepreneurs who've taken research out of the lab and built it into a company that's serving the world. These entrepreneurs are heroes, and the planet needs more of them. So tune in, learn from their successes and failures, and get inspired. Visit bountiful.org to join our community and realize your power to save the world. Welcome to Out of the Lab. I'm your host, Max Finder, and my guest today is Richard Adamson, who leads a technology company out of Calgary, Canada, doing industrial scale CO2 capture. So the origin story of the IP is really cool, and Richard has 30 years of experience commercializing industrial technologies, but I reached out to him specifically because of his reaction on LinkedIn to the Elon Musk $100 million carbon prize, which made a lot of waves the other week. So when we recorded, we thought the prize was basically saying that more innovation was required in carbon capture, which Richard argues is simply not true. So that was the basis of the discussion. The details of the prize have since emerged, indicating the focus will be more towards direct air capture, so literally pulling carbon out of the atmosphere and oceans, which is a much more nascent technology area. So either way, climate change is a huge near-term issue, so the debate around investing in innovation versus investing in good enough existing solutions is always a fascinating one. So enjoy this episode, and for all our bountiful members out there working on innovative direct air carbon capture technology, or those of you who have ideas for business model innovations in the industrial carbon capture space, keep getting after it. And now for the episode. Richard, thank you for joining us.
Pleasure to be here, Max.
So this is Out of the Lab for folks that are just tuning in, and we are talking with Richard Adamson. Richard, I actually reached out to you to try to interview you specifically because of this Elon Musk $100 million carbon capture prize that he announced, that I think there haven't really been many details that have emerged about it just yet.
Yeah.
But you know, you posted about it on LinkedIn. There were quite a lot of comments, and it's an interesting topic, right? The idea that carbon capture innovation is already there, and it's so crucial that we actually need to be deploying this technology that already exists and not trying to invent new things. And so maybe you could tell us a little bit about what he announced and what your gripe was with it, and where you think things are headed and where the opportunities are.
Yeah, so I appreciate you picking up on that. Musk didn't say very much, as you said. There's a whole lot of detail. He basically said he's going to put $100 million towards a prize for carbon capture for CCS, and not much else. Didn't say who would operate the prize. I'm guessing it's X Prize, since that's where SpaceX came from, but I'm just guessing there. So here's my concern about that. I think it's absolutely great that we see investment go into this field. Carbon capture and storage is, you can't get to where we're trying to get to in terms of climate without carbon capture and storage. CCS is required, especially on the industrial side, probably also on the power side, and a lot of sections as well. Something like 9 to 15% of the global emissions are going to wind up having to be dealt with through some form of carbon capture. So absolutely, it's an important field. He's right about that. Absolutely, it's a great place to invest in innovation. So my objection is not around investment. The problem is a prize program. Now, a few years ago, the X Prize ran a carbon conversion one called the Carbon X Prize. It was funded by NRG out of the US and COSIA, the Oil Sands Innovation Alliance out of Canada. And the whole point there was, given the lack of policy and regulatory that's actually enough to drive full-fledged carbon capture and storage, let's find ways of generating economic value out of the CO2 so that we can at least start creating maybe some niche applications for carbon capture, where we're actually producing some kind of a product that can be sold into the market, and that balances the cost of capture. It was a great concept, and it was out there. It was a new area that hadn't, what I call a blue ocean kind of an area of innovation. It was a perfect candidate for a prize. They set the prize up, attracted a lot of attention. A lot of early stage companies got involved. They just finished running the test program. It's on the final part of that competition. So I don't have a problem with prize competitions under the right circumstances. I don't have a problem with investment in the CCS space. The problem is that there have been full-scale CCS projects implemented. I think there's something like 28 of them running worldwide right now for a number of years. This isn't a blue ocean area. It's an area where there are mature technologies. Yeah, there's lots to learn: refinement, improvement, cost reduction. There are more innovative projects that are kind of working their way through the process. But what worries me is you start up a big prize and you say, hey, look at this wild and crazy idea. We're going to fund development of this brand new out of the box thing. And all of the investors in that space say, hey, wait a minute, this isn't ready for prime time. We better not invest in full-scale projects. We better not invest in more mature companies, because maybe they're not as ready as they say they are. Because look, there's all this attraction as though this was a brand new out-of-the-box concept. So I'm really concerned that what's going to wind up happening is you put a bunch of focus on something like a prize, and that gets picked up by the press and folks who aren't kind of insiders. And if there's a government policy that comes up that's going to support full-fledged CCS, then there's going to be a pushback from the general public, because there'll be a perception that somehow this is new, unproven technology, too risky, don't go there. And so that my objection to Musk's announcement is not a prize, and it's not CCS, it's the combination sends the wrong signal about the level of maturity of this industry.
And so what would that $100 million be better used for in your mind, just out of curiosity?
Well, I think it's for investment into companies in the space. And go out and find some of your buddies, put together a pool of money, and start cranking up the level of investment in early stage, mid stage companies that are moving technology off the lab bench. There's even if you wanted to go and take that $100 million and put it into early stage companies, that's fine. But the prize thing is all about attracting press and attracting. It's a three-ring circus, and it's the wrong circus for this industry. So it could invest it directly into companies in this space. Put it all into one that's at a later stage, or put it into a number of smaller ones. That's great. That creates that attracts more investors into the space. No problem with him putting money into the space. Welcome money from anybody.
And how many years ago was the COSIA, Canadian Oil Sands, and X Prize initiated Blue Ocean Prize? I mean, that, well, in your eyes, that was a good time for that. And since then, a number of promising technologies have emerged that are ready for pilot scale or commercial scale.
Well, I couldn't put a fixed date on it. The conversation in the industry around whether or not a prize was a good idea, and the length of time it took to get all the parties around the table and get it all set up, was quite a period of time. Predated the announcement of the program by several years. So I would say it's got to be at least eight years ago that the Carbon X Prize program started. That's the other issue, is if you set up a program right now, what people don't understand about industrial technologies is, if you've got a technology on the lab bench that's a unicorn, it's going to absolutely transform the industry. From the lab bench to implemented, piloted, enough hours in the field that it's considered to be de-risked so that engineering firms are willing to commit to it and companies are willing to invest. You're probably 20 to 25 years away from actual widespread acceptance. And so if you've got a choice between a technology that is either nearly commercial right now or commercial, that you can invest in the next few years, you can get that built in the next few years, or something on the lab bench that it's going to take 10, 20, 15, 10, 25 years to get fully commercial, you could be actually capturing CO2 for decades before this one starts even entering the marketplace. I'm really concerned that anything that creates delay in acceptance and rollout at scale is going to be actually going to be counterproductive in terms of addressing the climate issue.
Right. And so this is a critical space, carbon capture. And so the idea that we can be pulling CO2 out of the atmosphere now with the technology that we already do have is important to trumpet around the world. Yeah. So I guess I'm curious, what are some of the other areas that we should be, the blue ocean areas that we should be investing in now that, you know, it's okay, or there are areas where in 20, 25, 30 years, it'll be okay that that's when these technologies start to commercialize? Are there other areas that are similar to CCS that, you know, just don't have enough progress yet? Or
I'm going to back up a little bit here because you talked about capture from air, and there's industrial carbon capture, and that might, I use that generally to include even from coal-fired power plants and things, but I regard the power sector a little differently from the industrial sector, which I think is where the really hard problems lie. Capture from emissions from an industrial plant is very different from direct air capture, which many people are talking about. Essentially, it's 1,000 times harder to do direct air capture than industrial capture because you have to move 1,000 times more air through your equipment for 1 ton of CO2 to be captured.
It's possible that his prize might be oriented around that and less so on the industrial CO2 capture, but you're saying even that the opportunities in industrial CO2 are much more near term, much more important, much more doable nowadays. Yeah.
The opportunities for large scale rollout of industrial capture are real and present. What's required there is innovation around business models and investment models, and possibly how the systems integrate. So instead of being, a lot of the projects have been demonstration projects. So there's been a single point of emission, some transportation, pipeline or something, and a point of injection, either enhanced oil recovery or deep sequestration. And there you've got your project. One source, one pipe, one sink. The problem is there's single points of failure all over that thing. Yeah. What you really need if you're looking at industrial decarbonization is how do we deal with decarbonization systems or carbon management systems for industrial regions? So you've got multiple sources and multiple sinks, and a system that's robust enough so that over several decades, if companies fail or new companies come on or new processes get added, the whole thing can ride through the peaks and valleys over decades. So we need to stop thinking about demonstration projects and start thinking about regional integrated utility type carbon management.
And this is where business model innovation comes in. And so I saw in the thread, for instance, that you ignited on LinkedIn, Niall McDowell, who's a professor at Imperial College of London. And I just want to give a shout out to some members of the Bountiful community who are at ICL, and we appreciate, your involvement with us. But so Niall says that, hunting unicorns is one thing, but CCS is not a low TRL. Can you, and I know we've touched on this, but go ahead. Maybe explain TRL too, if you can.
Okay, technology readiness level. Yeah, okay, so there's a scale of technology readiness level from one, basically, I got an idea and maybe I've done some calculations on a piece of paper, to 9, it's fully commercial and being rolled out and implemented. And there's a range, a scale there, and it originated with NASA, but we don't need to go into the history on it. And Niall's absolutely correct in that, and really conversations I had with Niall a couple of years ago influenced my sensitivity to the idea that things that unjustly point in a direction of early stage technology create a perception of risk that winds up being a barrier to implementation. And R&D is just fine, but what we're trying to do is reduce carbon dioxide in the atmosphere and not publish papers. And so we really need to get this stuff out into the field. And Niall did some brilliant work looking into what the net sort of, let's get to 2050, what's the net effect of working with good enough technologies today and investing in getting that rolled out now versus investing heavily in next generation or the next one after that is going to require years of R&D, and then implementing that, even if it's so much better and the economics are so much better. If we're going to get to the same point by 2050, you're going to wind up having to, in 10 years, do massive implementation across worldwide in order to try and catch up to all of the time you've lost when you could have been building real plants and getting real work done. So, you know, this is that work by Niall a couple of years ago in our conversations really has kind of made me super sensitive to good enough is good enough. Let's get this stuff out into the field. Yes, there's room for improvement. The stuff we put out 10 years from now is going to be more economic and more compact and more standardized. And yeah, there's all kinds of room for improvement. There will be, but don't wait for the improvements before we start implementing.
And we should do them simultaneously, right? I mean, is there a mix of, let's say we had $100 million to spend. I mean, how much of it should go to deploying commercializable solutions versus continuing to invest in innovation so that in 10 years, these processes are improved? I know that might not be an easy, question to answer.
First off, in this space, $100 million ain't nothing.
It's nothing, right? It's a couple of plants, right?
Well, no, $100 million isn't a plant. It isn't even the beginning of a plant. I mean, full-scale plants are in the range of kind of, well, $500 million, $500 million. And one of the things that I think is a real opportunity for innovation and is likely to happen in parallel with this is all the plants that have been built are aiming for 1 million tons a year and up. That's considered to be economic. The economics for those plants is built around, we're going to do a whole mess of custom innovation, custom fabrication. Every piece of that plant is custom and it's the first of its kind. As we learn from those plants, we're going to learn ways that we could actually do it economically at a smaller scale. And that's really where I'm interested in, is let's figure out how to do 100,000 ton a year plants really cost effectively, or 50,000 ton a year plants. And let's figure out how to be able to standardize and drive the cost out of those smaller scale plants. But right now, right now, the focus is on these really large, really expensive plants. So if I had $100 million, as the song says,
sure.
I would put a significant amount of money not in trying to build plants, but in companies that are just on the threshold of moving into commercial. There's a number of players out there with CO2 capture, CO2 conversion technologies that are just starting to roll out into scale. And that's probably, with $100 million, you could have some impact in that zone.
And these are TRL, what TRL, 3 or 4?
I would 7, 8.
7, 8. Okay.
Yeah.
And so maybe this is a good opportunity for you to talk a bit about industrial climate solutions.
Yeah. Okay,
Go ahead.
I'm always willing to make a plug
Yeah,
for the
please.
company.
You know, it's
So our core technology, basically the front end of most of the carbon capture processes, is a wet chemistry process. So you get some kind of wet solvent in contact with gas, and that front end piece where the gas and the solvent come in contact is called an absorber. If you've seen pictures of these big carbon capture plants, what you'll notice is there's this structure in the middle of the plant that looks a little bit like a high-rise building. It's and that's the absorber column. It'll be 50, 60 meters taller, 15, 20, 25 meters on a side. It's a monster piece of equipment. It has an elevator bolted on the side. Well, our core technology basically reduces the size of that between 5 and 10 times. And it also tolerates a lot of next generation solvents that the current technologies don't use. So solvents that called precipitating solvents that drop out solids as they absorb CO2. We can handle the solids without plugging up. There's a number of things that we do that support next generations. So we're working with these, we're a supplier to folks that are putting end-to-end processes in place. And we're working with a number of these innovative companies to customize our equipment for their particular application in solvents and that sort of thing. And with companies in Europe and the US right now.
And so it's a better footprint and it's a more efficient system. Can you talk a little bit about how? I mean, I'm just curious, especially in the context of the what we're talking about with the Musk Prize. I mean, when was this technology, RFC? You call it regenerative froth contactors, right?
Yes.
Yeah. When was that invented, and how did you commercialize it? And what is the trajectory, and talk about some of the TRL stages and stuff like that.
The story behind this technology is really quite fascinating because it was invented in Maui, in a private lab in Maui, and it was privately funded. It started off with a technology using froth to capture drywall dust. One of the inventors was a drywaller, and one of his investors was a real estate developer who was doing renos at one end of a building and had a restaurant at the other end of the building, and the drywall dust was a problem. And anyway, this guy came up with a brilliant wet filter that removed almost all of the drywall dust. And then they commercialized that. It turned out that there just wasn't enough margin to sustain the business, but they managed to sell about 500 of these units into the marketplace, and it worked beautifully, but wasn't commercial.
What year was this?
Oh, it's got to be in the first few years of the 2000s. It's almost 20 years ago.
20 years ago, right?
Yeah. Anyway, they then moved on and got a contract from the U.S. Navy research with a little indoor air quality problem. Let's say they had to remove anthrax, smallpox, and sarin gas out of a background of a sandstorm with an air filter, and they actually got something like 99.999% efficiency and removal. They met a lot of their targets, but they they used too much energy to do it, and they actually didn't go on to commercialize that, but they learned an awful lot about froth and management of froth. And they subsequently took what they'd learned in the previous projects and developed the industrial capture system. So it was a long development process. I came along and started. I used to run a group called Carbon Management Canada, which funded academic-led research into industrial greenhouse gas technologies and policies and such. And I had identified that front-end absorber problem as being it's about a third of the cost of a plant. I said, that's the heart of a lot of the problems in carbon capture, is that absorber. And when I came across these guys, I just got really excited, started introducing them to guys developing the precipitating solvents and other things, and to some of the industry players. Anyway, when I retired from CMC, I went on their board. One of the first things I pointed out is Maui is not a place to commercialize industrial process equipment. Maybe we should set up shop in Canada. And so that's when we founded Industrial Climate Solutions and brought the technology in. And we've been doing the scale up and commercialization from here.
Cool. It's amazing. I love the trajectory of these things. It's awesome to hear the origin stories and see where they end up.
What I find, well, what's both really interesting and I find kind of exciting about it, and one of the barriers we face, is it did not spin off from a university.
Right.
There was no university involvement in it, and they weren't focused on publications in academic journals. And so one of the things that we've run into is there's an assumption amongst the investment community that everything comes out of universities, and therefore you should be able to present, here's the stack of academic journal articles around on which our innovation was based. Our innovation was based on a bunch of empirical, thousands and thousands of hours of empirical observations and modifications and adjustments that led to some real breakthroughs. But it wasn't done by academics, and it wasn't published in academic journals. And so it's been a real challenge because we don't fit the mold. We're more like the garage inventors of old.
It's very interesting. I mean, it's often that I don't know. It's the first time actually, at least on this podcast, and it's early days for us, but that we've interviewed somebody that took a technology not from academia and has been faced with this problem. And you probably saw a lot of academic. I mean, you saw a lot of academic technology at CMC, right?
Yeah. Oh, yeah. And I know it's been a lot of fun because we funded early stage academic research back a decade or more ago. And I got the opportunity to watch these. A number of them are now commercial, either startups or commercially operational now.
And can you talk a little bit about some of the lessons you learned or things you do better, differently, or I don't know, any tips? Because a lot of our listeners are in academia and looking towards research commercialization. And so, your experience there and now your experience as commercializing these technologies and deploying them. I mean, it's quite the gamut of experience. So, yeah.
So what really matters is, if you're not born rich, if you don't have Elon Musk behind you from day one, you're going to have to raise money, and you need to be really aware of who's going to invest in your business. And one of the problems is there's all kinds of accelerators and things out there that are absolutely great. They're really good, especially for absolutely green first-time entrepreneurs, because they kind of give you a mini MBA in a very short period of time. But understand, startup companies need to understand that as much as they like to think that they're the customer of the accelerator, they're not the customer, they're the product. The customer is the investor. So if you want to understand whether or not an accelerator is a good fit for you, look at their investors. If you've got an industrial product that you're trying to commercialize, and an accelerator says, we'd love to have you join us, review the investors. If all of the investors are Silicon Valley investors who've made their money out of Uber and PayPal and cell phone apps and things like that, they don't get industrial business models. They don't understand commercialization cycles for industrial products. They don't understand the issues involved. And the accelerator program is going to work like hell to make your business look like something that a Silicon Valley VC is going to invest in, which is not a fit for your business. So you're going to come out of that thing with all kinds of advice that tries to make you look like a Silicon Valley unicorn, when in fact that's exactly the wrong business model for an industrial product. So be careful. Don't believe the hype about the various accelerators. Look at each one, look at the investors that support them, and find the ones where the investors come out of industrial backgrounds. If you're doing an industrial product, find the ones that are doing, that will get your kind of business model. And likely the accelerator program will be trying to tailor your business to something that fits a little bit closer to the kind of business you run.
No, that's great. And when you were at CMC, how did you decide what academic inventions to finance? And how did you, I mean, was there an element of this has commercialization potential? I imagine there had to be. I mean, you weren't in the business necessarily of funding stuff for the sake of science. It was focused on commercialization, correct?
Well, it had a fairly heavy academic focus initially. So we started off, we had a group of advisors, academic advisors that were four academic team leaders who were absolutely great to work with. And we were covering policy, economics, communication, risk assessment and risk communication, as well as things like technology and, geosciences and everything. So we had a really broad mandate, and we were pushing towards multidisciplinary, multi-institutional research. So what we were trying to do was we were trying to find ways to break open innovation. We weren't necessarily saying this is going to be commercial, but what we wanted to do is say, how is this going to enable industrial decarbonization, either by breaking open new policy approaches or breaking open how do we communicate risk to the public so that they don't overestimate or have a distorted view of the risk involved, say with the CCS project or whatever. So there's more to it than how do you make money out of this technology.
Oh, go ahead. Sorry.
But the advisors were absolutely key. So we had advisors from across the country and across four very diverse, like industrial process side, from geology, geosciences side, from public policy side, from basically fundamental sciences approach as well.
And do a lot of the barriers that you were looking at then, do they still exist? How have they changed? And, what are some of the gaps that still exist that you would change?
Well, the policy side is evolving rapidly now. It hasn't evolved as rapidly as I would have liked to have seen it. It's really been in the past, with the US 45Q tax was probably the first really major breakthrough on policy since the work that we were doing with CMC. But for example, in Europe, the perception of risk for carbon storage onshore, essentially Europe has blown out all consideration of CCS with onshore storage. And I think that was an overreaction. It was there was a PR disaster back in the early days, and not that anything bad happened. It's just that there was a massive public outcry about, let's just say, a bad choice of a location in a highly populated area for an early stage project, and they just were unprepared for the public backlash. And that resulted in kind of an avalanche of every country banning onshore storage. So there's kind of barriers that are still there that are residual from lessons learned in the early days, or maybe lessons not learned.
Got it. I want to switch gears here. We had one person who wanted to ask a question from Mariah Energy, who's a PhD. I don't know if you know her or not, but she said—
I know Mariam well.
So Mariam had a question. She said, ask about the contribution of carbon capture equipment to the total cost. of carbon capture. Why should innovative design for equipment be considered as a solution to address the cost challenge?
Yeah, so it's both a cost and there's other barriers. So one of the issues is size. So yes, if you've got a large, reducing by 5 to 1 or 10 to 1 the size of that absorber column as an example, because that's where we focus. That reduces the length of time and the cost of construction. And that's a third of the cost of the plant. So if you can cut that in half, that's a sixth of the cost of the capital cost of the plant right there. If you can increase, there's other things that technically you can do there that actually reduces the cost of the rest of the plant. So modifications to technology or to the hardware can reduce the overall plant capital cost and operating cost. But what's probably more important even than cost is, picture this: you want to put an industrial capture plant in an industrial park on the edge of some city somewhere. You want to put a CO2 capture on an existing plant. If your absorber column has to be 60 meters tall, go out and get that permitted. If I can reduce that from 60 meters to 20 meters, that's not, this is an incremental cost improvement. That's, can I build it or can I not?
Right. And so it's doable in a lot of these applications that we're never going to get any type of treatment whatsoever.
Exactly. So, it opens up the possibility of actually getting stuff done, which to me, in the early days of getting a new technology into the marketplace, you want to drive into initial markets. They don't have to be big markets. You just have to get that. If you've got a that can make a go, no go decision on a project, like your end use customer who's going to build and operate this plant can't build it without your contribution, that's a far better place to start than somebody who says, oh, we can save 20% on our plant cost, but we're already regarded as risky. And if we bring in, we add another level of risk here, our investors aren't going to like it. Let's go with a more expensive old technology. It's not great, but hey, we just don't, we want everybody to feel completely confident, zero risk. And so it's really hard to penetrate the market on, even if it's a 20, 25% cost reduction, whatever, 50%, you're regarded as incremental when you're trying to get in. It's too incremental until you've got units in the field and operating. But for the other guy who can't get his plant built, you're far more attractive. So looking for those first plants where it's a go-no, either because technically you solve a problem that can't be solved or permitting or whatever, your first markets are the ones where you solve a problem that can't be solved otherwise.
And if you had to give advice to grad students, researchers, and young entrepreneurs looking to do something in innovation in carbon capture, would you advise them to try to build technologies that aim for this $100,000 plant call or $1 million plant kind of?
So
yeah,
it's
where are the opportunities for young people in CCS?
There's lots of opportunities in those spaces. What I would say is
we have a lot of listeners that are working on technologies. They're looking to start things. They're looking for technologies to license, for instance. They're trying to get in the innovation game in CCS. They're trying to make a difference in this space. And so, yeah, I mean, any tips?
So I would say that the best thing to do is go and get a job or do some contract work or whatever with your the end use customers, like with a large industrial emitter, with industrial process. If your interest lies in the industrial side, if your interest lies in transport, go work in a car company or something like that. But get to understand a customer and their pain as much as you possibly can. Don't start by looking at the technology. Start by looking at where is the pain in the industrial customers who, they're motivated, they want to reduce their carbon emissions. Go and work with them and understand their pain. Why can't they? From the outside, it looks like it's obvious they should just do X, Y, or Z. There's a reason they're not doing it. Get inside and understand exactly why they're not doing it, and then solve that problem.
That's good advice. What are some of the, do you have an example of that, for instance? I'm just curious, something that seems obvious that, an industrial emitter should do, but they're not doing, and some hidden reason for why they're not doing it. That's difficult. Yeah.
It's difficult. It's also difficult without disclosing information that I can't disclose. So, yeah. So it's really when you get inside, it's people point their fingers at. In Canada, there's a lot of objections around oil sands plants and the emissions from oil sands plants. And it's fine if you're sitting at home reading your newspaper to say they ought to do something about this. But very few people have actually been to an oil sands plant and seen the size of the operations. I mean, these plants are worth billions of dollars, and they pay for themselves over a period of 30, 40 years. These are not things that you just shut down, and they're not things that you can, and the revenue per day that's required is huge. So things that people generally aren't aware of is, if I put a piece of equipment onto this plant, that increases the probability that I'm going to have an unscheduled shutdown for a day. You're talking about, and I don't know the numbers off the top of my head, but tens of millions of dollars per day of cost if you shut the plant down. So what winds up, you have what you might call an extremely risk-averse customer who is not interested in, what the hell, we'll give it a shot. You don't do that on a multi-billion-dollar investment. And so in addition to, they don't have money right now because of oil prices and no investors want to invest in their businesses and all of those kinds of issues, they also have a problem with, they have a business to run, and trying something new. So I always see people coming up with saying, all you need to do to fix an oil sands plant is you just do X. Anybody who says you just do X doesn't understand the problem. It's really complicated, and the factors involved are really complicated and interconnected. And you need to get inside and understand, what are the considerations that the procurement group is going to have? What do the operators think about, and because the operators can stand up and say, it doesn't matter if the engineering team likes it. The operators might stand up and say, hell no, I'm judged on exactly how many barrels go through this plant. If you do something that shuts my plant down for a day, it's my butt on the line. So, you have to figure out, you need to get sign off from all of these different operating groups in the business.
Yeah.
So the better you understand the business and the operations and the pain points of each of those guys, the better chance you have of coming up with a solution that actually might get built.
That's actually exactly what we're trying to do at Bountiful, is take problem statements from industry to help guide some of the activities, even, sponsored research to technology licensing to job placements. We want to help guide people to, it's a problems first, initiative that we're building here, and it's the problems and the pain points that really drive a lot of this stuff. So we agree with you completely. Taking it back to $100 million Blue Ocean Prize, where should $100 million Blue Ocean Prize go today, in your opinion? Hydrogen, or whatever.
Well, I think there's lots of room still in carbon conversion. and in the hydrogen side. I would have to put some thought into exactly how to frame it, but I think probably, I'm not sure how you would structure a prize, but I really think that the thing that needs to happen is innovation around, again, a systems approach. How do you go from project thinking? Like, you don't scale an outhouse to a citywide sewage system by building millions of outhouses. You have to change the way you think about things. And so I think where the next big breakthroughs and the big opportunities are, and you're starting to see early projects that are kind of using the obvious pathways for hubs and clusters in the UK and Europe and such, Norway. And that's absolutely brilliant. I think that early experimentation is absolutely great. But I think there's room for breakthrough thinking of what are totally different approaches to either industrial or regional carbon management systems as opposed to individual projects.
Okay. Back to the business model innovation.
Yeah, you'll wind up with business model innovation, but there may be technology elements to it, and there's some things that some things that I'm kicking around in that area that are really early, but I think that's an area that whether or not any of the ideas I have make sense, it's an area that I think needs to be understood, because I know it's a nice thing to say that CO2 should be treated as a product that you can convert, we should generate economic value out of it. That's fine, but you can't generate tens of gigatons per year of tennis shoes or whatever, or any other product. It's, even concrete, you can't, if you're using concrete to store CO2, even concrete, there isn't enough to be able to make the level of storage that's required. So that's carbon conversion is not going to replace everything. We're going to have to do carbon capture and storage and conversion and all of the above.
Great. I think it's a great place to stop. Richard, thank you for joining us on Out of the Lab. Is there a place that people can find you? Twitter, LinkedIn, what do you prefer? What is your name there?
Well, LinkedIn, it's Richard Adamson. I'm on LinkedIn. You can find me there, based in Calgary, Canada. That's probably the easiest way. Also, you can look up for Industrial Climate Solutions, INDCLIM, SOL.com, inclimsol.com.
Excellent. Richard, thank you for joining us. Visit bountiful.work for more, and have a good day, everyone.
Thanks.
Thanks for listening. But now we need your help. We're building a community of scientists, students, entrepreneurs, industry leaders, and investors to commercialize meaningful technology and research. Join us at bountiful.work today to find opportunities and realize your power to save the world.